Let's talk about the display or uh, monitors. One of the optical actuator in digital devices like smartphones is the display or monitor. In fact, optical actuation is stored in memory as an image and is shown on digital display. So, controlling the intensity of each RGB LED pixel in a display produce the color that we can see it. So, with controlling the intensity of RGB LED pixel in a display or monitor, we can see the colors. Generally, in digital system or digital devices, we have two major monitoring system. The first one is LED monitors or display, which is called light emitting diode. And the second one is liquid crystal displays, LCDs. LCDs do not produce light. Instead, they block light from passing through them. The LEDs, light emitted or emitting diode, actually produce the light itself, each LED, each diode. But in the case of liquid crystal display, they do not produce lights. Actually, they block light from passing through them. Okay, proprioceptor sensors. These sensors indicate the current position of a system like a smartphone or robot. In other words, for distinguishing the location of a system, we use from proprioceptor sensors. The first one is accelerometer, and the second one is global positioning system known as GPS. Okay, let's talk about the accelerometer. We can say that an accelerometer is a sensor that measures acceleration. So we have two different methods for measuring acceleration. We can say that acceleration is an abrupt change in its direction. So in the case of a smartphone, it can be used for counting your footsteps. Counting your footsteps. When you are walking, when you are running, the acceleration sensor in your smartphone can count your footsteps. Another method is measuring force of gravity. Force of gravity. In fact, accelerometers are sensitive to the force of gravity. So, using this sensor in a smartphone, the orientation of display can be determined. I will show you the image about this topic. So, accelerometer has two tasks. The first one is counting footsteps, and the second one is detecting the orientation of display. As an application of this sensor, accelerometer, in a digital device, let's give an example about the laptop, your notebook. We can say that this sensor detects sudden change in motion When this change is greater than normal one, okay, this change is defined in your notebook for the accelerometer. Now, when your laptop fall down from desk to the floor, the sensor detects this sudden motion and puts the hard drive into a collision-safe mode very quickly before the laptop hits to the ground. Okay, as you see here, I talked about one of the tasks of accelerometer in your smartphones. When you are walking or running, it can calculate your footsteps. And in the case of detecting the orientation of the image, because we said that accelerometer is sensitive to the force of the gravity, when you turn on your orientation mode in your smartphone, actually you are turning on your accelerometer sensors. So according to the force of gravity, your smartphone can determine the direction and orientation of the image or videos in your device. GPS, or Global Positioning System. This GPS determines the position of an object on the ground using information which is transmitted from satellites. These are the satellites that you can see here. In this picture, we have 24 satellites deployed in space above the surface of the Earth. And these satellites orbit around the Earth once every 12 hours in a day, or in other words, 2 times in a day. Okay, generally, for determining the position of actually 2D position, two-dimensional position of an object on the Earth, we need to have at least three information of satellites. And for determining a three-dimensional position of an object, we need to have the information of at least 4 satellites. Now, let's look at here. I want to explain that how we need to have this information and how does the GPS work in our device. Suppose that this is an object. This object can be your smartphone, can be everything that has GPS and so on. For example, I called it it's an object, it's a device. When you turn on your GPS, this GPS start to give and start to receive the signal from the satellites. For example, suppose that we have a satellite called S1 here. Now, this signal, this distance from these S1 satellite up to these devices can be calculated according to this delay of the signal that this device received from this satellite. Suppose that we call it R1, and this R1 actually is a radius of a circle with the center of S1. Suppose that this is a radius. This R1 is the radius of this circle with the center of S1. Now, our device receives the information of this satellite. Now, suppose that we have another satellite here, which is located here. This is also S2. Again, our device received this information also. And the delay of this signal which is received to this device is our distinguish our distance, and this distance also is the radius of this circle with the center of S2. Now, as you see here, using two satellites, we can find two interconnection nodes. One of these two nodes is our position. But using two satellites, we cannot exactly determine which one of these nodes is our location. So we need to have at least another information of satellite that distinguish exactly the position. We know that our position is here. So suppose that, for example, we have another satellite here, S3. Again, our device received this signal, which is called S3, and also this SR3 is a, oh, it's wrong actually. Suppose that this is a circle, doesn't matter. Oh, what happened? Okay, now the common, it's so important, the common information which is sent or received or transmitted from these three satellites are the exact position of an object. For example, I received a latitude, longitude, and attitude from this satellite, and also receive this information from this satellite and also this satellite. Now, if I receive the common information, common latitude and common longitude, it means that my location is here. So our GPS can detect the position and location of this device and show us where we are. We learned that for locating an object, we need to have information of three satellites. Let's calculate and learn that how can we calculate this location exactly. For this reason, for simplicity, suppose that we have XY coordinates like that. Look at here exactly, please. This is so important. This is my X, Y. Suppose that my first satellite is located here at the center of this coordinate system with the 0 and 0 coordinates. And we know that this satellite, this center actually is a center of a circle, is a center of a circle. S1 R1, and another satellite, suppose that located here S2 with the coordinate of D and 0. Suppose that this distance is D, and also this satellite has a distance with object in R, and this satellite is a center of a circle. Okay, now we could find two nodes with the interconnection of actually the interface of these two circles, this node and this node. But we don't know the which one of these nodes is our location. For now, suppose that we have two nodes. What is the coordinate of this node? Is x, for example, xg and yg. This is x and this is y. What is the coordinate of this node? X, g, minus yg. According to the properties of the circle, we know that if we have a node on this side of the circle, vice versa, this side we have only the same node in the reverse direction. The x is the same, y is reversed. Now let's write the circle equation. What is the equation of a circle? Suppose that I have a circle like that. Now, according this equation, let's write the equation of these two circle. For this one, for S1, I can write that the center of this circle is 0 and 0. It means that A is equal to 0 and B is equal to 0. So I can write that x squared plus y squared is equal to R1 squared. And for S2, I also write that, actually these are xg, say, how can I write the equation for this g squared plus yg squared is equal to R2 squared. Now, if I find this is the first equation, this is my second equation. From first equation, I can write y squared g is equal to R1 squared minus xg squared. With substituting these 3 squared into second square, I can find that xg minus d squared plus R1 squared minus xg squared is equal to R2 squared. And with expanding this term, xg squared minus 2dxg plus d2 plus R1 squared minus xg squared is equal to R2 squared. Xg squared is deleted, so I can find that from here xg is equal to R1 squared plus R2 squared plus d squared divided by 2d. I could find my xg, my position, only the x position. What about the y position? Easily, with substituting this force equation into third equation, I can find the yg. Yg will be plus minus, because we have yg square, we need to write plus and minus square root r1 square minus xg square. With substituting the xg here, you can find two values for y of g. It means that you will find this location and also this location. Now, again, with writing the circle equation for the third satellite, like that, you need to write the equation xg minus a2 plus yg minus b is equal to r3 square. And again, with substituting the x of g into this equation, you can find y of g from here. Now, the common y with this value, and this value is our exact coordinate.
In equation 4, you write r1 square plus r2 square. Why isn't it minus? I think it should be
Which
minus.
one? Which one is minus?
Yes, teacher, it must be minus.
Oh, yes. Sorry. I have to write. This is my mistake. Thank you for your attention. This is I have written all of these information that you need, and I talked about all of them for x1, xg, and y of g, r1. And here I have written the equations. You can find it here and also here. And at the end, I have written that with solving the similar equations for R1 or R2 and R3 leads a unique location for GPS. Okay, the sensors that we have discussed up to now were positive sensors. Were passive sensors. What is the meaning of passive? Actually, it means that these sensors, like mechanical sensors, optical sensors, acoustic sensors, and so on, all of them detect the energy that is produced by another source. For example, the microphone detects the sounds as an acoustic energy that is produced by a music instrument or by us. But active sensors are the sensors that produce their own energy and then is sensed. Now we have two different types of active sensors. The first group are sensors that detect the presence of objects as people counters at the store entrance or barcode readers. The second group of active sensors are sensors that determine the range of an object, such as infrared ranging system and sonar system. Okay, generally, we will talk about the two sensors, active sensors. The first one is the sensors that determine the presence of object, The second one is the sensors that determine the range of object. Okay, using active optical detector, we can determine an object. This sensor, as you see here, consists of two parts. A transmitter and the receiver. How does it work? Look at this figure. The LED here transmits an infrared light and actually infrared light beams, and this receiver also receive the infrared beam. This LED transmits the infrared light beam, and this black one receives this beam. Look at here. When there isn't any object between these two components, transmitter and receiver, the receiver detects the light energy and produces a signal for the system that there is no object. Actually, these receivers do like open switch. Now, when an object interrupts the beam, the receiver does not detect any light energy. This is the light energy. But here, when an object interrupts, so it produces a signal for the system that there is an object. It means that it perform like closed switch. Actually, it can find that there is an object here, or this kind of sensor determine the presence of the object. Now, what is the meaning of infrared? Actually, infrared or IR is an electromagnetic radiation with wavelengths longer than those of visible light. Infrared light is not visible light, so it is invisible to the human eyes. The second one is barcode scanner. As you see in the figure here, this is a black and white barcode that are laser scanned. Laser scan this barcode. We know that the white color bounces back the light and the black color absorbs the light. So when the laser shines on the white and black regions in the barcode, the white section bounces the light and the black one absorbs it. It means that we can have a digital signal at the output of this sensor with the zero value for white space and 1 value for black space. This is the white space with the 0 value, 1 space with the black value. As I talked about the infrared light, which is not visible for human eyes, so one of the devices that uses infrared light is acoustic camera. As you see in the figure, this camera has an IR emitter and IR detector. This section emits the light, infrared light beam, and this section detects the infrared light beam. Which infrared beam? The infrared beam that is scattered from the object. The emitter sends a beam using a lens. When the beam encounters an object, the light scatters. The detector lens collects some of the scatter lights, so the detector determines the object's range from the location of the light spikes on the detector. This is the application of infrared light in actually camera. And as you see here, for modeling this camera and finding the range of the object, we suppose that we can actually model this lens, emitter, and detector with the pinholes, and this beam is go through these pinholes to the object. And also the scattered beam is passed through these pinholes to the detector. So we can model this section of camera with these two triangles. This distance is called X. This distance is called F. The distance between two lenses are called S. And this distance is range of the object, the distance of object from the camera. Now, from the geometry, we know that the relationship between these two triangles are like that. R divided by S is equal to F divided by X. Now, from here, we can find the value of R. The value of R is a range of object, is a distance of object from the camera. Okay, as a last active sensor, we finished this topic, the sensors and actuators here today. As the last one, let's discuss about the sonar system. The sonar is a technique that uses sound propagation. This sensor is used in robots for detecting the location of an object or an obstacle. A sonar emits an acoustic pulse with the approximately 40 kilohertz. So the sound pulse travels at the speed of sound. The speed of sound is 343 meters per second. But in air, the speed of sound in air is 343 meters per second. Then a reflection is produced. The reflection is produced when the acoustic pulse encounters an object. So this echo is detected. This sonar echo waveform is applied to a threshold tau. Now, the time at which the echo amplitude first exceeded the threshold, defined as time of flight, TOF. For example, here the T of OF is 703. Now, using this information, the time of flight, we can find the range of the object is equal to C. C is the speed of sound times TOF divided by 2. This is the application of sonar system in sensors.